Hi guys, salamat sa inyong patuloy na ginagawang pagsubaybay dito sa ating discussions about statics of rigid bodies. At itong ating magiging discussions ay continuation ng nauna kong ipinakita sa inyo about friction. Ginawa kong series ito para lalo ninyong maintindihan ang konsepto ng friction para sa inyong preparation sa board examinations. At narito ang ating pangalawang problem. So in the problem sabi dito, the three blocks with weights as shown in the figure are placed on a 20-degree incline so that they are in contact with each other and at rest. Determine which, if any, of the blocks will move and the friction force acting under each. Assume that under blocks A and C, the coefficient of friction is, or R, okay, F sub S equals 0.5 and F sub K, or the coefficient of kinetic friction, equal to 0.4, while under block B, the coefficient of static friction is zero point 0.3 and the coefficient of kinetic friction is zero point 0.4. And I'll be showing you okay, our figure. Okay, the figure okay, look like this one. So there are three blocks as shown here, okay, A, B, and C, whose weights are indicated such that block A has a weight of 60 Newton, block B has a weight of 40 Newton, and block C has a weight of 20 Newton. And all these are okay, in contact with each other and at rest, and they rest okay, on an inclined plane 20 degrees okay, to the horizontal. Ngayon, gawa natin ng analysis itong ating problem. Sa una natin dapat ma-establish ay ano ba yung motion meron sa blocks. So, kinakailangan makita natin muna dito kung ano yung mga possible motions. And let us analyze one by one. Ang unang possible motion na makita natin o pwedeng mangyari sa block ay itong block A that will slide alone. So, only block A will move. But the question is, possible ba ito? Okay? So, we can do it, but we can test for the motion if we are going to analyze okay, block A as free body diagram. So let us try to consider that we analyze, we draw the block A as FBD. So here is our inclined plane that makes 20 degrees from the horizontal. And above this plane, meron tayong block. If we are going to consider this axis that is parallel to the inclined plane, be called as axis, then an axis perpendicular to it may be labeled as a y-axis. And if we're going to show a weight, this weight will be making therefore an angle of 20 degrees, okay, from the y-axis because the plane makes an angle of 20 degrees and y is perpendicular to the plane. Diba? And this weight would have a component parallel to the y-axis. And also, meron din siyang component dito na parallel to the plane. Then, this block will now be subjected to a normal force coming from the plane. And let us call that normal force be N sub A. And because the motion is directed downward, kung isipin natin yung gagalaw, yung A, we will expect therefore that there will be a frictional force that will be exerted by the plane upon the block and whose direction will be upward. Now, ang tanong dito ay, gagalaw ba itong A kung ang coefficient of static friction ng block A at ng plane ay 0.5? So, masasagot yan na gagalaw kung, sabi dito, block A will move down the plane if the component of the weight parallel to the plane, itong tinutukoy kong ito, yung itong may arrow ito, ay greater than the maximum frictional force that can be developed under the block. So, meron daw paggalaw itong A kung itong component na ito ay magiging mas malaki dun sa F sub A. Sa makatwid, we will be testing the magnitude of the frictional force that will be developed under A and this component of the weight that is parallel to the plane. Now, knowing the frictional force be equal to the product of the coefficient of static friction multiplied by normal force acting on the plane. Therefore, we have to compute okay, this N sub A, by summing of forces along y equal to 0. So that, okay, N sub A natin will be equal to this component of the weight. And this will be equal to 60 multiplied by cosine of 20. Hence, from here, kay masosolve natin itong N sub A na ang value ay equal sa 56.382. And then, okay, from N sub A, we can compute for this F sub A, this being equal to the product of the coefficient of static friction by multiplied by that normal force. Hence, it will be equal to 0.5 multiplied by 56.362. And therefore, our F sub A is equal to 28.191 Newton. So what shall we do with this? So kinakailangan mai-compare natin ito dito sa component ng weight kay parallel to the plane at malaman natin kung ito baga ay kayang pigilan yung pag-slide ng block A. So let us try to compute this component of the weight. Okay? Yung component ng weight parallel to the plane is computed as W sub T, and that is equal to 60 multiplied by sine of 20. That if we will be substituting, computing for the value, then this component is equal to 20.521 Newton. And let us try to compare, no? This one, this component of the weight, which is 20.521, is less than 28.198. Ang ibig sabihin to, malaki yung possible na frictional force na ma-develop. Okay? And therefore, because this component is less than the maximum frictional force that can be developed under A, therefore, ano masasabi natin? Okay? The block A will not move alone. Ano? So, sabi nga kasi dito, since the maximum friction that can be developed under A is greater than the component of that weight parallel to the plane, then block A alone will not slide down the plane. Ibig sabihin nun, hindi siya pwedeng gumalaw ng solo, ano? Hindi siya pwedeng gumalaw ng solo o mag-slide out. Iwan yung dalawa, B at C. Pero itong tanong, ano? Tanong ano yung second possible motion? So, dahil above A ay merong B, so pwede namang naitutulak nitong B si A. Diba? So, ang ibig sabihin nun, there is a possibility also that both blocks A and B will move together. Pero ang tanong ay, possible ba yon? So, and how do we know that they will be moving? So, we can test for the motion of the two if we're going to isolate, particularly the block B as FBD. Kasi alamin muna natin dito kung yung block B alone will be moving down the plane kung sakaling walang yung A sa ilalim niya. So, let us try to isolate here our block B as free body diagram. So again, we have here our plane making an angle of 20 degrees from the horizontal, and on top of the plane, nandyan yung ating block B, whose weight is equal to 40 Newton. So assuming natin na itong axis na ito, which is parallel to the plane, be called as x-axis. Hence, the axis perpendicular to it will be called as our y-axis. And this weight will be directed downward, and this weight would have a component perpendicular to the plane as indicated by this one, this line, and another component parallel to the plane, which is this side. And because the motion is directed downward, there will be a frictional force that will be exerted by the plane upon block B, which is directed upward. And this frictional force can be computed as the product of this coefficient of static friction multiplied by the normal force. Although initially it was established that block A, itong ating block A na nasa ilalim, will not move down the plane because the maximum friction that can be developed under A is greater than the component of the weight parallel to the plane. But it is also possible that it may be pushed down by this block B. So, posibleng na itulak itong block A ni block B. Diba? If block B alone will move. But how are we going to know if block B will be moving? So, we should be able to establish whether this component of the weight parallel to the plane is greater than the frictional force developed. Hence, we compute for the normal force by applying summation of force along y equal to 0, so that n sub b, this one, will be equal to the component of the weight perpendicular to the plane, and that's equal to 40 cosine of 20. Hence, we can compute for n sub b to be equal to 37.588. And that, okay, we can compute for the frictional force by multiplying this normal force by the coefficient of static friction, which is zero point 0.3, thus giving us a value of F sub B equal to 11.278. Now, looking at this figure, okay, this component of the weight, so we have to compute for the component of the weight parallel to the plane, and that is equal to 40 multiplied by sine of 20, and whose value, when computed, will be 13.681. Now, looking at the two values, you will notice that the value sub t, or the weight component of the weight parallel to the plane, is greater than the maximum frictional force that can be developed under B. So, anong ibig sabihin mangyayari doon? So, we can say therefore that, okay, if B alone, okay, if B is alone on the plane, therefore B will be moving down the plane. Okay? Kung sakaling B lamang ang nasa ibabaw ng plane, therefore B will be moving kasi mas maliit itong F sub B kaysa doon sa component ng weight parallel to the plane. But since B is being blocked, as it is indicated in the figure, B is being blocked by A. Diba? Then the two blocks will move as a unit if the total frictional force under A and B is less than the total components of the weight parallel to the plane. So, gaya nga na naobserbahan natin, bagamat doon sa analysis natin, itong block B will be moving downward kung solo siya, but it is being blocked by A. So, mangyayari lamang nagagalaw yung dalawang A, yung dalawang blocks A and B, kung yung component ng forces or ng weights parallel to the planes from A and B is greater than the sum of the frictional force developed under A and B. And therefore, what shall we do? Okay, so what we do is to make an isolation or the FBD of the blocks A and B as a unit. So ipakita ngayon natin dito yung ating A and B together sa unit, okay, on top of the plane, which is at 20 degrees from the horizontal. So here is now our blocks A and B that they are together. Okay. So again, we will be considering this as our x-axis, and perpendicular to it shall be our y-axis. Okay. The weight of A is downward, okay, making an angle of 20 degrees from the horizontal, from the y-axis. Similarly, ito namang ating weight will be making an angle of 20 degrees also from the y-axis. This 60 Newton weight will have a component, okay, perpendicular to the plane as well as component parallel to the plane. And so with this weight of the second block under B, meron tayo ditong component perpendicular at component parallel. Ano? And this plane will be exerting a force, okay, on the blocks, and we will be calling it as N sub A. Ganon din dito sa side nito, sa block B, meron tayo ditong N sub B. And because the motion is downward, hence there will be a frictional force that will be exerted by the plane upon these blocks. So meron tayong F sub A dito, at meron din tayo ditong F sub B, which are both directed opposite the direction of motion. Hence, they are both upward. And whose value can be computed using the magnitude of this NA multiplied by the coefficient of friction, which were already computed a while ago. Diba? So, pinakita natin dito that this F sub A is already computed at 28.191, gaya na pinakita ko kanina. No? While this F sub B, the frictional force that can be developed under B, is already computed at 11.276. However, this component of the weight parallel to the plane, okay, from the 60-pound Newton block is equal to 20.521 Newton, and this component of the 14 Newton block parallel to the plane is equal to 13.681. And if we're going to, okay, examine the total frictional force, okay, which is the sum of FA plus F sub B, okay, and whose value is equal to 28.191 plus 11.276, okay, so that this magnitude will be equal to 39.467. And the total component of the weight parallel to the plane is equal to the sum of WAT and WSB, which is this component. Okay, itong dalawa na ito, pag inad natin yan, so we shall have a component, okay, parallel to the plane having a magnitude of 34.2 202. And let us try to examine, the frictional force that can be developed is greater than the component of the weight parallel to the plane. Hence, mas malaki itong ating frictional force dito kaysa sa kay component. And therefore, what will happen? So, mangyayari dyan, since the maximum friction that can be developed under A and B is greater than the total components of the weight parallel to the plane, then blocks A and B as a unit will remain stationary. So, hindi siya makagagalaw. Mas malaki kasi itong pinagsamang F sub A at F sub B kaysa doon sa pinagsamang component ng weight parallel to the plane from A and block B. Ba? Okay? There is another possibility that all the three blocks will move together. Pwede rin mangyari na yung tatlo namang blocks ang gagalaw. So, kailan mangyayari yon? Okay, it will happen if may tutulak itong block C, itong dalawang blocks A and B. Sabi nga kasi dito, although it was already established that blocks A and B will not move, there is still a possibility that all the blocks will move since there is still block C above them. Meron pa kasing block C above them, di ba? If the surface between block C and the plane is smooth, and that if the component of the weight of C parallel to the plane is greater than the maximum frictional force that can be developed under the block C. And that the difference between them, okay, is great enough to push the two blocks downward. So sabi, mangyayari daw na, okay, gagalaw yung tatlo kung okay, smooth yung surface between block C and the plane at yung component ng weight parallel to the plane mula doon sa C is greater than the maximum frictional force that can be developed under block C. And that the difference between these two forces is great enough to push blocks A and B as a unit. Hindi ba? So, anong ibig sabihin nun? So, malalaman natin dito ngayon yung motion if we will be isolating block C alone, kung yung block C alone ba is gagalaw o hindi. So, we can make it by analyzing or by isolating FBD of the block C alone. So, let us try to determine that. So, we will be determining if block C alone will move by isolating this block as FBD. Again, let us imagine that this is our plane, okay, making an angle of 20 degrees from the horizontal, and above this, meron tayong block C whose weight is 20 Newton. Ano, pakita ko na yung weight dito. Okay, ito yung kanyang weight. So this weight has a component perpendicular and parallel to the plane as indicated. Okay, and there will be a normal force acting here, and because the motion is downward, okay, there will be a frictional force that will be acting upward. And whose magnitude will be equal to n sub c multiplied by 0.5. And therefore, we have to compute for n sub c by, okay, summing up forces along y equal to 0. And that, okay, here, we can compute for n sub c to be 20 multiplied by cosine of 20. And this will be equal to 18.784 Newton. And this n sub c, okay, will be multiplied by 0.5 for us to be able to get f sub c, di ba? So, multiplying it by 0.5, we shall be getting f sub c to be 9.367 Newton. Okay, but the component of the weight parallel to the plane, this component, okay, can be computed as, okay, 20 multiplied by sine of 20. And that value, okay, when simplified, is equal to 6.84 Newton. Now, looking at this value, the total component of the weight is just 6.84, while the maximum frictional force that can be developed under C is 9.367, which is greater than this component. Therefore, ano masasabi natin? Okay, masasabi natin that, okay, the block C will not move alone. So, if block C cannot move, ba? And blocks A and B will not also be moving. Therefore, what conclusion are we going to have? So, conclusion natin, okay, on the motion of the blocks, ano sabi dyan? All the blocks will remain stationary. So, ibig sabihin, walang makagagalaw sa kanila. But, if there will be, okay, no blocks that will be moving, how are we going to compute for the frictional force that will be developed under blocks A, B, and C? So, magsimula tayo dito sa itaas, okay, sa block C. Okay, if the friction, if block C will not be moving, okay, therefore, okay, the frictional force that can be developed, okay, and on under block C, okay, is just equal to the maximum, to the static friction, okay, developed. And this will be equal to, okay, uh, 6.84 as we have computed earlier. Diba? While under block B, okay, although block B remains stationary as we have computed, but its motion is almost impending. So kasi kung solo lamang kasi siya, gagalaw siya, no? But it is being blocked by A. Hence, the motion is impending. And because the motion is impending, the block is still on the condition of stage at rest. Hence, okay, the frictional force developed under B is the maximum static friction that can be developed, and that is equal to 11.276. While under, okay, and the difference, actually, and the difference between, okay, the component of the weight, which is 13.681, and this frictional force developed, is being transferred to block A. Ito yung itinutulak, ito pinagtutulak ni block B papunta kay A. And there is a difference of 2.405. Now, under block BA, okay, aside from the component of the weight of block A parallel to the plane, block A is also being pushed by B by a force equal to 2.405 Newton. So that the total force causing an impending motion on the block A is equal to K 20.521 plus K 2.405, and that gives us a value of 22.926 Newton. Hence, block A remains stationary, but the frictional force developed is equal to 22.926 Newton. Okay? So that's how we show the solution to the problem. And I hope that with the explanation I made on how do we compute, okay, for the frictional force developed, and how do we determine, okay, whether there will be motion or not, is very, very clear to you, and you're able to follow, okay, the solution. Once again, thank you very much for watching, and I hope that you continue supporting my channel by subscribing. Thank you.